Okay, so today's lecture is going to be on section 1.4. We are going to be talking about radians, arc length, and angular speed. The common thing here is that we are going to be traveling on a circle. We want to be able to locate our position and essentially use a circle as a kind of number line. In algebra classes, essentially since elementary school, you study about association of numbers with the number line. So you have a straight line with an arrow in one direction indicating the positive side of this line. You have a unit of length, and then you go ahead and mark points on that line. And if you go in the opposite direction, you have the negative numbers in that location. You will have some fractional numbers on the same line. You could have square root numbers on this line. You could have all sorts of numbers, all of them sitting on that line. Sometimes you are not traveling on a straight line, and you still want to figure out how much you have traveled, just like you are in your car and the odometer is recording how much you have traveled. The car is not necessarily going on a straight line, but you still want to know how far you have traveled. One of the simplest shapes on which you could be traveling could be a circle. So you could have a circle and something, imagine like a racetrack or just some place that you go for jogging or something. You want to do the same thing, that is, start at some location. That would be your origin, and then start going in a certain direction and consider that direction as your positive direction. So you could be going around, and you want to know how much you have traveled. So you want to mark your trip by numbers, just as you did on the real number line. Well, we can just easily do that. It's just that you have to live with the fact that we are going to have a little bit of a difficulty when we come back where we started. But after we come back where we started, we like to continue. Like if you are on your car and you are going through this race, quite a few laps to go through, so you go to the next lap and then next round, and you go around on the same circle. Of course, you have to draw it separately so that you see this is the third round we are going. So the idea is to take the real number line and wrap it around the circle. That's what this whole section is about. Instead of going a straight line, we're going to go on a circle. Well, what do we need? Basic thing that we need from elementary geometry is a relationship between the circumference of a circle and its radius. So a circle can be flagged by a variety of measurements. You can talk about its radius, so you can have a radius r. Sometimes you want to talk about its diameter d. So far, what's the connection between these two? Diameter is just 2r, or the radius is half of the diameter. The third measurement you could use for talking about the circle is, well, how far is it going to be if you go around the circle just once? That's going to be the circumference, or the perimeter of the circle. So C, one of the nicer and more important formulas in elementary geometry is a connection between this circumference and either radius or the diameter. What's the connection between C and R? 2 pi r, is that right? Or between circumference and the diameter. That is pi d. Who is pi? Well, pi is that famous number, which is the ratio of the circumference to the diameter of a circle. It is approximately something like that. Since ancient times, people have been busy trying to figure out digits of pi. You know, they know it to several billions of digits. These are some of the digits that has been known for like 1,000 years or something. So if you go way back, you see this approximation 3.14. If you go look around in ancient literature, you see approximation coming as far as 9.2. You dig some more, even several hundred years ago, this many of the digits of it were known. Okay. Now in high school, they might also have told you some other approximation for pi. Some of the favorite approximations are like what, 22 over 7. So you might have seen this thing that they tell you pi is approximately 22.7. If you have taken a lot more geometry class in high school, they might have told you that the ancient Chinese had another approximation, which is this nice looking fraction, 2 5s, 2 3s, 2 1s. So 355 over 113, what is that? Let's see. So 355 over 113, 3.141592, 6 digits. Let's see. So this approximation starts to differ at this location. At 6, instead of 6 you have a 9. So this one covers all the way up to here. 22 over 7. 22 over 7, what is that one? That's another famous fraction. You just get 2 digits there. So if you have 22 over 7, 3.1428. So 3.14, this one becomes 2. It doesn't go that far. So that is up to here. That's good, just a little bit. And there are whole history is revolving around it. So it's a non-trivial number, something that we need to live with. You need to find out on your calculator how to access that number. Some calculators have a button, just you press it and the whole pi is there. Sometimes you have to go through some contortions to get it. So you check your calculator manual to see what does it tell you. So sometimes there is a button right out, so you just get it. Otherwise, you can perhaps go and get it in so this would be a little bit more elaborate ways of getting a pi out of your calculator. But pretty much every new calculator has a button for pi somewhere in it. Just go ahead and find out. So we need to know about pi. What kind of a complication does it create for us? Well, it's not a nice number in the sense that it's not like one of our numbers that we see here. So when you want to take a real number line and wrap it around this, things don't mesh up very well, because you start at 0, you go around, this says circumference is 2 pi r. So by the time you come around to this point, you have gone through 2 times pi, that is 6.28. So when you have come back here, you have traveled 6.28 of the radius, and that is no longer a nice number like 0 itself. It's not a whole number. So that's the complication we have to live with. How are we going to handle that? One of two ways. One of them is to recognize pi as our kind of yardstick. So we say, okay, let's live with pi. Let's accept pi as a good number to live with. So, okay, I start from here, 0. First of all, I forgot to mention, just to make our discussion easier, we are going to take a special kind of a circle. We call it a unit circle. Unit circle, and a unit circle radius is taken to be r, so that we don't have too many things floating around us and distracting us. So unit circle, it means we have taken the radius of the circle to be just 1. So that is nailed down here. Now, as I go around the circle and come back here, how much have I traveled? That is the circumference of the circle. Circumference was 2 pi r. So by now the circumference is 2 pi times 1, which is just 2 pi, which is approximately 6.28. 2 times pi is 6.28. So as I go around here and come back, I can say by the time I've come back, I have traveled 6.28 units. That's a little bit uncomfortable to talk about. So you might say, okay, I started at 0 and I went around and came back. Now I am at the travel 2 pi. So now we are recognizing pi as a number that we are comfortable to live with. So what if I go half circle? I come here. If the whole thing is 2 pi, what's half of it? That's going to be pi. So that's pi. What if, well, I decide to go a quarter of the distance? So this racetrack or whatever it is, if I go from here and just stop at that location, how far have I traveled? So if the whole thing, this is pi, this is going to be what? Pi over 2. So we are just marking the 4 corners of the universe for us. This is 0, pi over 2, pi. Who is this guy? This is 3 of these quarters. Each of these quarters is pi over 2. So what is this guy? 3 pi over 2. Is that right? This is 3 quarters. Each quarter is pi over 2. 3 of them makes 3 pi over 2. Of course, 4 of them, 4 pi over 2 is just 2 pi. What if I decide to continue? So I have gone through the racetrack once. Now I'm on my second lap. By the time I have reached this point, how much have I traveled? Okay, so I've gone around the circle, come back here and continue another quarter. So by the time I arrived here, I had gone through 2 pi. Then I'm traveling another pi over 2. Take just treat this thing like anything in a plain algebra. That is, you can take 2 pi and write it as 4 pi over 2 and add pi over 2 to it, so it makes 5 pi over 2. Or the common denominator here is 2. I have to divide 2 by 1. I get a 2. Multiply by that. That makes a 4 pi for me. And another pi makes 5 pi over 2. So if I go through a whole circle and another quarter circle, I have traveled 5 pi over 2 units. What if I continue and arrive at this point one more time? So what has happened so far? I have gone through 2 pi and then an additional pi. So that point could also be marked as what? 3 pi, very good, 3 pi. Now let's continue, reach to this point. Second time we are arriving at this point. So what number should be associated to the same point again? So again we have 2 pi and 3 pi over 2. So 2 pi for the first round, 3 pi over 2 for the second partial trip. You have to get used to adding fractions with pi's all over the place. What is 7 pi over 2 is the answer here, 7 pi over 2. So we have to get used to living with pi in all of our numbers. Now pi is our like a new yardstick. By the time I've made it through the circle for the second round, I have traveled how much? 4 pi and so on. So we have two issues. One is the partial trip that you have made, that indicates whatever fraction of pi you have traveled, plus how many full rounds around the circle we have gone. Each round of a circle is 2 pi. If you have gone through n rounds of it, it's going to be 2n pi plus whatever extra you have traveled. So number of rotations times 2 pi plus the partial trip is going to indicate the number that is going to be used as a marking here. Now, you could decide to travel in the opposite direction. In the opposite direction, we are going to treat the situation just the same way as we did on the real number line. We just indicate the same number with a negative, meaning if I start from here and back up to this point, by then I am going to be at what location? It's a quarter, so it's a pi over 2, but since I'm going in the negative direction, what should I write? Negative pi over 2. What if I make it back to this point? So that's going to be negative pi. What if I make it to this point? What's another marking for the same point here on the circle? So this is a quarter of it is minus pi over 2. 3/4 of it is going to be minus 3 pi over 2. If I make a full round and come back here, by the time I have arrived at this location, it's at minus 2 pi. So if I go clockwise, I have number of rotation times 2 pi times a negative to indicate the number that I have to deal with. And then I'll add or subtract to that whatever extra I'm going to have. For example, if I go through a whole circle clockwise and come back to this point, what should be my designation for that location now? So 1 round and a quarter round in clockwise direction. What number should I use? Minus 5 pi over 2. So 1 round is minus 2 pi. So I have minus 2 pi. And then another quarter circle, which is minus pi over 2. Be careful when you are taking common denominator with negatives all around you. So the common denominator is 2. This becomes minus 4 pi. The sign travels to numerator. And this is minus pi. And this is minus 5 pi over 2. That indicates this location. Okay, so this was the story of going around the circle in quarter steps. Well, sometimes you want to be a little bit more refined than that. You don't always take your pizza and divide it to 4 pieces. Sometimes they take it and divide it to 6 pieces, 8 pieces, or something like that. Let's see what happens if we travel and we want to divide our trip to 6 equal pieces. So this is kind of like imagining your pizza being divided to shape of a hexagon or something like that. So it's, again, if you start from here and make it all the way back, we are going to be at 2 pi. What would be location of this point then? We have gone through a 1/6 of the entire trip. So 1/6 of the entire trip, you can write it as 2 pi 6, or you can write it as pi third. So this is going to be 0 pi third, or 2 pi 6. By the time you make it to the second slice, what is your location? 2 of these slices, so 2 of them, of course, 2 pi third. Third slice, so 3 pi third, or just a pi. Fourth slice, it's of course 4 pi third. By the time you make it here, it's 5 pi third. By the time you have made it here, it's 6 pi third, which is just 2 pi. And then you can go around the circle some more. Same story with any other of these nice divisions. We can take our circle and this time divide it to 8 pieces and just mark some important points for ourselves. So this is going to be 0. And of course, now I am going through an octagon, so every one of the pieces is pi over 4. So this is going to be designated as pi over 4. This one we were there before. Two of these things makes it pi over, what's that? This location we have seen before. How about this location? Yeah, it's going to be 3 pi over 4. This is, we had seen it, opposite, diametric opposite is pi. Who's this one? It's 5 slices. Each slice is pi over 4, so 5 pi over 4. This is 6 slices, 3 pi over 2. 7 slices, 7 pi over 4, and so on. You have a bigger party and you want to divide your pizza so that everybody gets something, so you might say you could use any number. Of course, if you decide to divide your pizza to 7 pieces and such, you are going to be a little bit of out of practice. For whatever reason, they don't do that. We are picking these special angles because we mentioned among all angles, some of them are easier for us to deal with. So suppose you divide it to 12 slices. Who is this one? First encounter we have here. Remember 2 pi. We are dividing it to 12 pieces, so every piece is a pi 6. So first one is pi 6. This is 2 pi 6, which is same as that pi third. We had seen this before. This one we had seen in the first cut that we had done. So a lot of these points we had already encountered. Pi over 2. 4 of these slices, 4 pi 6 is same as 2 pi third. This is the same point here that is showing in this slicing as well. This is new. Who is that? I've gone through 5 slices. So for 1, 2, 3, 4, 5. So each slice was pi 6. So this is going to be 5 pi 6. We were there here before. This is new again. 7 pi 6. This one we had visited. 8 pi 6 is same as 4 pi third. This one we had visited before. That is 3 pi over 2. How about that? This is 9, 10. 10 pi 6, same as 5 pi third. We had visited this place before. This is new. Who's that one? Yeah, 11 pi 6. Make it one more step. 12 pi 6 is just your 2 pi. And so on. So you can make any of these pictures. So when you look at some of the problems in the book, you are going to see a peculiar looking circle. So there is a circle there, and they have perhaps a marking here, a marking here, a marking here. It's of course 0 and pi over 2 for you. This is pi 6. This is pi 4. This is pi third. This is just the markings for famous angles we dealt with. And we are going to talk about it again. So if you see this kind of a circle with 3 marking on it, and the markings can go on the other side, you have to just figure out where the locations are for each of these things and find your place. Okay, so one style of remember the issue was we want to take a real number line, wrap it around the circle. We have the issue that these whole numbers don't work very well with our pi. So we have to resolve the issue one way or another. Either use pi as our yardstick and every number is going to have a pi on it. The alternate is to insist that really that's what I want to see around the circle. And that is going to bring us to the issue of radians. Radians come about when we take a real number line whose unit is same as a radius and wrap it around the circle. Let's see what happens. Next issue is what is the deal with radians. Radians is going to be a unit of angle. Is a very probably new to you, but it's the scientific unit that is used in calculus and high level courses for reasons that you are going to see there. It makes life a lot more easy, and it's a lot more natural than using 360 degrees. 360 looks like an arbitrary number. It's like somebody slept and woke up next day and said, I'm going to take a circle and divide it to 360. Why 360? Why not 500? Why not 200? What's so special about 360? We said that has either astronomical reasoning, or cultural reasoning, or whatever it is. Maybe it has to do with our sun and planet and everything. But what if somebody was on another planet? What would they do? The issue of radians is like this. Suppose I have a circle. I want to go around it, and I want to mark my spot. I start with this yardstick. My original yardstick is the radius of the circle. I take a string, the length of this radius, and just let it lay over on the circle. I take a string the size of this radius and put it on the circle. Wherever it ends, okay, that is my holy grail. That's my main point. That's my 1. This was 1, so I was supposed to take a unit. Let me redraw this thing. I had my real number line. On that real number line, I have this radius as my unit. So that is 1 radius, that is 2 radius, that is 3 radius, and so on. I take that and wrap it around my circle. So by now I have gone through 1 radius. If I want to go more, this is going to be 2 radius. I want to go more, it's going to be, say, 3 radius, 4, 5, 6. How much more do I have to go to make it all the way back? How many radiuses or how many radii does it take to make it all the way back where I was? Approximately how many of these pieces of strings, length of the radius, does it take to cover the entire circle? What was our formula? C was equal to what? 2 pi times r. Who is 2 pi? 2 pi, 6.28, etc. 6.28 of these strings is going to cover my circle. That is, 6 is going to be short, 7 is going to be extra. If you want to stop right here, it's 6.28 r. Our difficulty is living up with that number. Our previous approach was to say, okay, 2 pi r, tough luck, deal with the pi. Pi is your new number. But what if you want to say, no, I like my old numbers. I like my whole numbers, 1, 2, 3. I want it like that. I don't want to pi anything. Okay, now you have a price to pay. Say, okay, take your string, put it here. That is first place. Put the string again. By now it's 2 string length, 3 string, 4, 5, 6. By the time you come back, it's 6.28 r. Okay, what does that have to do with any angle? What it has is that if you connect this to the origin, that is going to be our famous 1 radian. This is 1 radian. That is the new unit. That's the unit people use in calculus, engineering, everything like that. The unit they use is kind of a visible unit. It's about 60 degrees, a little bit less. It's not like 1 degree. One degree is a very small angle. You cannot really easily draw it. But 1 radian looks a lot more natural and a lot easier to digest. It doesn't have anything to do with the stars and planets, and how many days you got to have in a year, and what the Babylonians said or didn't say. It is natural to the circle. You see, I take a circle, take its radius as a string laid over here, connected to the origin. That is my unit. Okay? So that is the unit. Now, since we wanted to make our life easy, and we said, okay, let's reduce the clutter, not have too many things to deal with, so we are dealing with a unit circle. In a unit circle, the radius is 1. Radius is 1. I take that radius and lay it on the side. That is going to be 1 radian. Now, on your calculators, you have to go find the button that measures things in this unit. Again, depending on make and model, either there's a button that has letters D, R, G on it, or there is some other button somewhere that has the word mode on it. And then you have to press the mode, and it gives you a bunch of choices. It all depends on your make and model. Perhaps there is something there that says something about angle, or perhaps the words degree, radian, and G stands for grad. Then you press some button to choose radian. Once that radian is chosen on the display of the calculator, you are going to see, instead of a D, which stands for degree, everything being done in degrees, there is going to be a little R showing up. Okay, so everything we do here, you have to also track it on your calculator. Say, okay, who on my calculator is responsible for changing my units? If I wanted degrees, if I wanted radians, that's how it's going to be. Who is grad? Grad, people who like the metric system try to sell that. Just nobody bought it. So grad meant some engineers say, we like the number 10 so much. Let's take this thing as 0 and consider this 100 grad. So this is going to be 200, this is going to be 300. By the time you have made it back, it's 400 grads. So grad is a little bit smaller than a degree. I haven't seen anybody use it. So, so this one, everything that you do in calculus revolves around this issue. And everyday usage, of course, everybody uses degrees. Sometimes you want to do conversion yourself. You have to handle some problems. So let's deal with conversion between units. How many units do we have? Well, if you are a mechanic, your unit for an angle is actually a whole round or a circle. We talk about rounds per minute, RPM, or something like that. So a big unit that we have is a round or circle or rotation or whatever other name you want to use for it. So this is the entire circle itself. Then we had the degree. So degree was 1/360th of a whole circle. And then we had the radian. And then, of course, we also have grad to deal with. What is the conversion between these things? One circle, how many degrees fit into it? If I go around it, it becomes 360 degrees. How many radians does it fit? Let's go back here. This is 1 radian. Almost 6. So what should we say exact measure? How many of these things, how many radii make a whole circle? 6 1/4 or 6 and a little bit. How do you make it precise? So that is 2 pi radians. Okay, again, that pi is showing it's either, you want to say beautiful head or ugly head, whatever it is, it's showing itself. So 1 radians. 2 radians, 3 radians, 4 radians, 5, 5, 6, and a little bit. That little bit makes 6 and almost a quarter, 6.28 radians makes a whole circle. That is exactly 2 pi radians. So remember, pi is just 3 point something. And how many grads? How many grads did we say makes a whole circle? 400 grads. Okay, if you remember this, you can go about your conversions easily. One circle is 360 degrees, 2 pi radians, or 400 grads. So let's practice a little bit. Let's pick some of these famous angles that we had. So convert 30, 45, 60 degrees to radians. Say 30 degrees out of 360, that means a 30-degree angle is 1/12 of the whole circle. No, the circle is 2 pi radians. So what did I do? I took 30 degrees, divide by 360, multiplied by 2 pi. What is the reasoning? 30 out of 360 tells me what fraction of a whole circle this thing is. It's 1/12. Well, whole circle is 2 pi radians. What is 1/12 of 2 pi radians? So you go ahead and simplify this thing. So you say this is 1/12 of 2 pi radians, or pi 6. That is what we said here. If you take this circle, which is 360 degrees, you divide it to 12 pieces. Every piece is 30 degrees. That 30 degrees also pi over 6. The distance you have traveled in front of this thing on a unit circle is same as pi over 6. Okay, you do the next one for me. Suppose we want to do 45. I want to convert 45 degrees to radians. How do I convert it? So 45 out of 360, that tells me 1/8 of a circle. Multiply by 2 pi, so that is 1/8 of 2 pi. You have to simplify, that is a quarter of a circle. What if I wanted to do the other one, 60 degrees? So 60 degrees is 1/6 of a circle. Each circle is 2 pi radians, so that's 1/6 of 2 pi. So that is pi third radians. So in short, degree divided by 360 times 2 pi is going to be your measure in radians. What if you wanted to go backward? Let's go ahead and do that in another page. So if you want something to memorize, but it's better to understand where does this whole thing come from. It comes from this equivalence. You take your number of degrees divided by how many degrees makes a whole circle, multiply that by how many radians are in a full circle, that converts it to radians. So once again, one circle or one rotation is 360 degrees, which is 2 pi radians, which is 400 grads. So suppose I have convert pi 9 radians to degrees. So pi 9th, what fraction of a whole circle is it? Pi 9th radians, whole circle is 2 pi radians. So that's a fraction of a whole circle. Each circle is 360 degrees. So I divide by 2 pi, multiply by 360. It is common that some of these problems, like half of these problems, the angle that is given in degrees has a pi in it. In that case, you have to remember to simplify. So this becomes 1/9. 1/9. I have to divide it by 2 also. So this pi and that pi cancel each other out. Times 360. Now you go about your simplification any number of ways you want. How many degrees would that be? Say 20 degrees. There are 20 degrees, so that is our. So you convert back and forth. What do we have? Radians. If you have radians given to you, you multiply, divide it by 2 pi, multiply by 360. That is going to give you your answer in degrees. You might see a slightly different formula somewhere else. Say radians divided by pi, multiplied by 180. That is 360 divided by 2 is already 180. You might want to use that slightly simpler formula. That would be the same thing. Okay, now we want to give a slight generalization of, remember, we want to travel on a circle. We talked about the unit circle just to make our life easy, but people who are on a racetrack don't say I'm on a unit circle. The circle is whatever it is. It has its own radius and such. And then you might travel some partial trip on this. You want to know what is the connection between the radius of the circle and the amount that you have traveled and the angle that you have traveled. So I have my radius, I have some angle, let's call it angle theta, and I have the length of the arc in front of that angle. These three components, we want to know what is the connection between these three. Well, for the case of a whole circle, we know that if you go all around, the connection between circumference and the radius is that circumference is 2 pi radians. But what about special case? So let's suppose I am on a circle. Okay, let's make up a problem and then I give a formula if you have time. Suppose we are on a circle of radius, say 2 miles, and we are going to travel on some piece of this such that the central angle happens to be, say, 110 degrees. What I want to find out is that how much did I travel? So I'm on a racetrack. It has a radius of 2 miles. I go so that my angle from the center has moved by 110 degrees. That is, I have rotated 110 degrees. Question is, how much have I traveled? Well, let's simplify the issue first. If I had traveled whole circle, how much would have I traveled? If I go through the entire 360 degrees, by the time I come back, radius is 2. What was the formula we had? Circumference is equal to 2 pi r. So if you had traveled through the whole thing, you would say I would have traveled 2 pi times 2 miles. I have traveled 4 pi miles if I go all around. But I didn't go through the whole circle. I just went through 110 degrees of it. Well, how many degrees is the whole thing? 360. I went through 110 of them. So what fraction of this thing did I travel? I have 4 pi is the whole thing. If I just go a little bit, just 1 degree, what should I divide this thing by to figure out how much I have traveled if I just go 1 degree? You know, like take your circle, how many pieces should I make out of it so that this will be 1 degree? If I just go and cut my circle to lots of little slices, how many slices do I need so that this will be just 1 degree? 360. 1 degree is 1/360th of the whole circle. Now, if you have traveled over 110 degrees, so that's 110 times that. So, in general, what do we have? If you have a circle of radius r, and you have gone through an angle of, let's call it d degrees. You want to know how much you have traveled. Say, okay, r, take my r. Multiply by 2 pi. That's going to be a whole circle. I have traveled d degrees. D out of 360. Every degree is 1/360th of the whole circle. If I travel through d degrees, that's how much I have traveled. So this is the arc length of d. So this is that is the whole circle. That's a fraction of the circle you have traveled. Now we don't have time to cover what if the answer was given to you in radians. That's going to be a lot easier. Let's do that on Friday. Okay? So you start section 1.4. We still have a couple of more things to say before we close the section.